Alrighty, guys. How's it going? So I'm going to talk about, my talk was A Tale of RavenHQ. Really what I'm going to talk about is we're heavily involved in ops, obviously, and we get a lot of questions regarding ops stories. So I figured we could use this time to kind of go through what we do for ops and how you guys can apply it to what you're doing. So who's heard of RavenHQ and who's actively using it? Okay, awesome. I was afraid to ask that question, but. So we're essentially the official cloud hosting provider for RavenDB. And what does that mean? It just means that we offer cloud hosting and we make it really easy to get you up and running. And I think that the key thing that people don't realize when they're using RavenHQ is that you're actually commoditizing your ops and support. We spend a lot of time looking at how our databases are performing, how customer databases are performing, and actively doing things to make it as good as it can be for everyone. We're also tightly knitted with the product support team. So if you have issues, and we get issues with RavenDB, you can actually use our support ticket as a channel to figure out if it's an ops thing or if it's a product support thing, which I think is pretty cool. So what do I want during this? What?
It's not so cool when you wake me up.
That is true. So what do I want from this demo? I'd like to provide an overview of the challenges we face from ops perspective. I also kind of want to talk about ops considerations. A lot of people don't think about that. They just put stuff in a database, and that's cool. And it'll get you up and running for a little while. But RavenDB, like any database, you've got to make considerations there. So we'll talk a little bit about that. And then just tips to avoid pitfalls. Now, I think David and Kajana and a lot of people kind of covered a lot of what I was going to cover there, so we might kind of go through that pretty quickly. But I also want you guys to ask questions, and don't wait until the end. Go ahead and interrupt me. I don't care. And I would also like sharks with freaking laser beams on their heads. So our ops challenges at RavenHQ, part of our offering is a shared hosting environment. We also offer dedicated hosting and a mixture of the two. So we have customers that have vastly different usage requirements. And that includes high reads, a massive amount of writes, burst loads and burst writes where they're doing massive batches. We've got guys running hundreds of indexes on a small result set and on large result sets. People running different mixtures of MapReduce. All of those things come into play, and we need to provide normalized performance for all of them. And that's a really big thing. It's a really hard problem to solve. The other thing that we have to do is we've got to make money, right? So we actively monitor that stuff, and we try to manage scale and manage capacity so that we're getting the biggest bang for our buck. And then also managing noisy neighbors in our shared environment is something that we spend a lot of time trying to prevent. So specifically, for what does that mean for you guys? Server performance considerations. There's a lot of ways to, we run on AWS and also on Azure privately. But there's a lot of ways that you can scale and can choose your server configurations. And these are kind of the main considerations that I think are applicable. CPU and indexing, I think those are kind of obvious ones, but I kind of want to talk about why those are obvious, why those are important. CPU is important from kind of two dimensions. One is you have lots of indexes and you have things indexing in parallel. The quicker that they can finish up their batches of indexing, the quicker they can move on to something else. So when you're talking about eventual consistency, a lot of times you want to go to your customers, or you're looking at your view and you're saying, how important are my consistency SLAs for this one view? If if your indexing is slow, you're getting more eventual consistent results. That can be an issue in some of your views. So managing CPU helps with that. Now, that doesn't mean that you should rely on it and reduce or try to guarantee consistency on your indexes, but you do use it to manage what that consistency is going to look like. And also concurrent requests. So specifically, we'll talk a little bit about hosting, but we run on IIS. Your CPU is directly related to how many requests you can have concurrently. So it's a pretty big deal when you have a high amount of reads and a high amount of writes. CPU goes directly to how many concurrent requests you can have. Memory, this one, Raven's actually really good at managing resources. It does take what it wants, but especially in a multi-tenant environment, I think it does really well in saying, hey, I want to back off of not using so much resources for this one guy because I see this other guy using a lot. It's actually pretty good at that. So memory does help with indexing because you're essentially storing a lot of that stuff in memory, especially with 2.5, right? You're not writing it, you're not flushing to disk every time you're doing that. You're holding a lot of memory. So the more memory you have, the faster things index. Concurrent requests, you know what? That shouldn't actually be there. It's not actually that important for memory. Multi-tenancy, though, it's a pretty big deal. Not so much running a lot of databases concurrently, because if they're not being used, then Raven does a pretty good job at turning it off and on. But things like doing massive upgrades, turning a server off and turning it back on, these databases need to get up and running, especially if you're hitting all the requests at the same time. Memory goes directly into play with that, and it'll affect the startup times and stuff like that. So it's a pretty important thing to look at. The biggest one, it's kind of an obvious one, but it's the one that is the hardest to kind of manage, is disk I/O. Disk I/O directly affects what your write operations are going to look like. Since we're trying to do ACID, you're essentially writing to disk, right? And so if your disk is slow, those requests are going to be slow. If those requests are slow and you also have a high amount of reads, well, IIS is going to favor those requests, and it's going to queue up those reads. The more you queue, the more your CPU goes up, and suddenly you see high CPU, you think that Raven's using CPU when really it's your disk. So the other thing that comes into play, not so much on 2.5 because they've done a lot of performance improvements there, but having the ability to write to disk quickly will help you write larger batches of indexes, which makes your indexing times really fast, and you're able to support a lot more indexes and have really, really quick indexing. So Dan is going to actually have a talk around replication and sharding and horizontal scale. So I'm not going to talk too much about that. I don't want to water down his Kool-Aid or anything. But there is when you're considering servers, we talk about horizontal scalability. It is cheap. Specifically when you're running in the cloud, though, you need to take into consideration scaling up, adding more memory, adding more CPU, adding faster drives, versus the cost of scaling out. It is very cheap to scale out, but sometimes just adding faster drives is a better way to go. So we were talking about this yesterday, but there's hosting considerations for how you host RavenDB. There's two ways to host out of the box. You've got running as a Windows service and running as IIS. I don't think that one's right or wrong, but there's definitely trade-offs and considerations that you should take into consideration. Really, visibility and control are the two main things. So hosting as a Windows service, that's like full control. It's really easy to manage. It's really easy to install. You can start and stop, not really have that many issues. You you can pretty much run a lot of them side by side without that much configuration. They've streamlined a lot of that. What you do lose is a little bit of visibility compared to IIS. Now things are vastly improved in 3.0, but in 2.5, what you have are the built-in Raven performance counters and some perf counter stuff for the Windows service, which isn't that much. Also, you kind of lose out on when you want to do custom things, and this will be a little bit more in the IIS realm of things, but if you want to do things like rewriting or advanced logging and that type of stuff outside of the Raven pipeline, then you're essentially rolling your own stuff at that point. Hosting IIS, the good there is you get a little bit more visibility into what you're doing. IIS request logging, I think it's pretty important. Not necessarily for your day-to-day, but being able to do triage and that type of stuff, being able to see the requests for the last, the last week, really kind of helps us gauge where our traffic's coming and what style of requests are taking longer. Now, if you control your whole stack, then you could probably get that by looking at other places like maybe your web node, and if you're using in Service Bus, maybe looking at that to see what endpoints and operations are taking longer. But being able to triage that, we've found that is very helpful.
Yeah, we use Splunk to
yeah.
index all of our stuff, and we actually do it for our app servers and our Raven.
Right.
And the correlation between the two, having two side-by-side graphs, has been instrumental.
Right. Right.
It's easier to look at it.
Yeah, and especially when you start seeing these spikes in requests, when you're dealing with bringing servers down and seeing that you're getting timeouts while it's failing over for replication, being able to correlate those are definitely important. So that type of triage has been invaluable for RavenHQ, and I can see its benefits. So performance monitoring. So we can all say that performance counters kind of suck, but in 2.5 and with IIS, they're a really good way to figure out what's going on, specifically with IIS, and seeing how your request times and queuing and that type of stuff. And we'll get a little bit more into that in the next few slides. So this is probably not beneficial to most people unless you're running multiple things on the same server. But being able to have control over throttling. With IIS, you can throttle CPU, you can throttle memory. You've got a little bit more control over that, so that if you do have, Raven's really not that greedy, but if you do have things that are greedy, and Raven's taking some of that stuff, and you don't want to wait over time, you want to dedicate it, it's definitely a good way to go. I think another major benefit is that IIS has been around for a while, and their modules, a lot of people and businesses have put in time in writing modules that you can take and use with RavenDB. So you've got advanced logging that's kind of built in. Rewriting modules are helpful if you have a complex system and you need to reroute stuff. So stuff to prevent denial of service, those types of things are definitely important. The not so good with IIS, there's a lot. So it is a more complex install. You have to, Raven makes it really easy in 2.5 to set up SSL and that type of stuff. That's not so easy in IIS. Setting up an IIS website, especially automated, is fundamentally harder. It's complex configuration, mostly because of the last line. You're essentially constrained by the IIS and the ASP.NET pipeline. What does that mean? Well, it means that if IIS and ASP.NET have rules against how many requests it's going to do per second, or what limits do I have on request sizes, all that stuff, you're going to have to take into consideration and tweak, right? So there's some configuration that's safe by default, and it works really well. And other places, just like WCF, it's a nightmare, and you have to go and tweak the hell out of it. So you do have to think a lot more about that configuration in the IIS version than you do in the Windows Service version. Go ahead.
Is there much overhead involved using IIS?
I don't think so. I mean, we tested early on and we didn't see a major. Where there is overhead is when you get to the larger request sizes, there's a bit of overhead, but it's negligible, I think. Other questions? Okay, so I'm assuming we're running on IIS, so I kind of want to give you the lay of the land when it comes to perf monitoring of what we think is important. Now, granted, consider that we're using IIS and there's a mass volume of requests going. So these are important to us, but they could be important to you, especially if you're running on slower hardware. So specifically with IIS, some of the cool performance counters that you get is current connections. What that will help you if you don't have Splunk or you don't have really good monitoring in your outer layers, what you'll get is the number of requests, essentially the number of requests per second. When you start seeing high spikes, you can correlate that with things failing or the amount of requests that are timing out and those types of things. It's pretty good for that. Request execution time, that is essentially will help you figure out how long your requests are taking. And sometimes it's not necessarily a matter of load. It's a matter of you essentially writing massive amounts of writes under a distributed transaction. There's a lot of things that can go into play there, but that is instrumental in figuring out what type of requests and how long they're taking. Request queue, that's more on our side of the fence, but seeing IIS will essentially queue requests, and you'll start, after a while, you'll start getting 503s when you hit a max queue depth, right? Now all that's tweakable, but you need to know where you're starting to get into dangerous grounds, and it's pretty helpful for that. And then another one is request wait time. So you might not be seeing high spikes in requests, but what you're seeing is that those requests are taking a long time, and that you could improve a bit by maybe adding more CPU. This will tell you how long things are, on average, how long things are waiting to actually be processed. Go ahead.
How do you correlate the request coming through our application layer with so I can correlate, this specific activity driving these specific.
Right. So he mentioned one option is using Splunk, right, or using something that will aggregate stuff, and then you can use essentially times, and you can add. Do you add headers to your?
Yeah. No, it's just a request log.
Okay.
We don't do anything like real crazy.
Yeah.
But we have hit occasions where we blow out the request header size and
Right.
and so we had to go and figure that out.
Right.
It was unintuitive because we didn't have that logged in, but that's the only occasion where it felt like we needed it.
You can also add header IDs to your stuff, and yeah, it'll get disregarded, but it'll get logged, and so you can start correlating your logs that way. So I mentioned that disk speeds are really important. I think it's probably one of the most important things that people forget about doing, especially when you're running on AWS, because you get, what is it, like 500? 100?
Yeah, like the standard drives are the equivalent of 100 IOPS.
Yeah, okay, so 100 IOPS is what you get. So, that you think that's bad, but if you look at what Raven does, it's a very read-heavy system. That's good, right? Most of the stuff's going to be in memory. You really don't need it. But if you're using it in conjunction with in-service bus, or you're using it with an event store, or you're using it with something that has a high number of writes, that's where you're going to need, or your consistency SLAs in your index are very short, then you need to start looking at higher IOPS at that point. And so being able to see your read and write, the request per second that you're doing there, and then your total transfer per second really helps out in considering. especially if you start seeing spikes in CPU, go and take a look at what your disk speeds are doing, and you'll probably see a pretty large correlation. Because like I said, Raven's pretty good at letting go of CPU when it doesn't need it. But if it needs to write, it's going to write, and that has a direct correlation with CPU. Yeah, in Amazon? Yeah, so we're in Amazon, AWS, so we use EC2 instances. Right, yeah. So I guess it directly depends on what your rights per se. It's all about SLAs, right? So it's about our numbers are going to be vastly different because we're dealing with hundreds of customers, right? Or a few hundred databases, or on some of our servers just a small amount of databases. But what did you say? Like, are you asking like IOPS or just requests per second?
For example, is that ever related to some average response time from this?
No, I mean, it all depends on how much you're writing concurrently. And that's really what it is. Because if you look at Raven and how it queries, right, a lot of that stuff's already in memory, right? A lot of its indexes are in memory. So read performance is not as important as your write performance, I would think.
So, I ask this because last week we are encountered some production issue. The everything run on that database server is RavenDB or not.
Can you repeat the question?
Oh, sure. So he's asking, what's an ideal number of requests per second? And that's a very objective question because you need to take a look at what your write SLAs are and how much you're writing. So now you were saying something else.
Yeah, the reason I ask you because you're running many clients, right? So I think you may have some average time or some level in your mind. So which means if you look at something, you find probably out of the range or something, that's give you a load, right?
Right. So we have on every single one of our boxes, we have essentially heuristics on how many people we're going to run and how many requests per second we're going to do.
Right.
And as soon as we start seeing our request times kind of fizzle out, then we start reprioritizing people and putting them in other places. But each one of those heuristics are different per box because we've got some people that have high write scenarios, right? And so that's why I'm saying it just depends on your SLAs. Sorry, I'm not punning your question. It's just that there's no 42. It's 42. Yeah.
Okay.
So another pretty big thing that we wish people would consider when they're running on RavenDB, or sorry, RavenHQ, and that we get asked a lot is when should I use another database? So David mentioned having different SLAs on changing. I forget what the lingo that you use, but having different consistency boundaries and change boundaries. Or what's the word that you were using? Say what? Yeah, units of change. So I call them usage and availability SLAs. But so when you have documents that essentially have a lot of burst writes, that can drastically affect the indexing SLAs of your other collection types, right? So if you have something that's really important to have, a small consistency window on, but you're going in and you're adding, a few 100,000 documents using bulk insert for another collection type, those are going to affect each other. And so if you not making that SLA is important, then you would consider moving that to a different database. That's one option. So another thing that you see is a lot of times when you're mass writing to the same document. An example would be had a client that was storing GPS locations for each one of their devices. So they could potentially have hundreds of thousands to a few million devices, and it's essentially updating the GPS location a certain amount of time. Now you could argue, and no indexing there, you're essentially doing load to just find current location. You could argue that maybe RavenDB definitely can do it, but maybe you could use a key value storage or something for that. But if you wanted to intermix that with other stuff that you're doing in RavenDB, put it in its own database. It doesn't require indexing, but it'll affect the SLAs of other things indexing. Very large documents. This is like a key thing in RavenHQ is people see that they have very large documents and they only have a few 100,000 of those, but it affects when they go and add new indexes for other collections that their indexing is slow. And it's because they're loading up this massive document, and it's every time that they write to that thing, it's affecting the indexing times for their other stuff, and they don't know why. So I already covered this one, but MapReduce is kind of important. So a lot of times your execs say, hey, I want KPIs on everything, right? So what you see is that you're gonna one good way of doing it is writing MapReduces on a lot of your collections to be able to aggregate it and show a nifty number or a nifty aggregate, and that's all fine and dandy. But if you have 70 of those and you have your operational indexes in there as well, running that on the same database is probably not a good idea because it's going to affect your SLAs for those indexes. So, and I'm not going to get into the replication portion of it, but you can replicate to a different database those documents and run those indexes on this other document database to just run the indexes for your operational reporting there. These two are not so obvious, but parts of your system. One of the things that we've seen is that you have a large company and they go and they purchase a Raven database, right, or a set of Raven databases, and then they stick all of their databases. So it's not just a separate database. They're running multiple databases, but they're all essentially under the same Raven server. So then you have some people that want to stick around with versions, other people that don't want to go down at certain times. When you have different SLAs for those things, different release cycles, different availability SLAs, not only choose to use different databases, but maybe even running different Raven servers. And Raven's just as good as running one Raven server on a single physical box or running 10 Raven servers on a physical box. It's just like running multiple tenants. Management is a lot harder because you're having to remember host names and ports if you don't configure right. So it's a lot harder to manage, but from an availability perspective, it's a good thing. From an ops, a DevOps perspective, sometimes it's better to run that way. So that goes into your question, I think was yesterday or the day before, or yesterday, yeah, regarding I want to bring down a single Raven database. You could totally do that. He showed you how you can disable a Raven database, and that'll all work. If you're wanting to bring it down for maintenance, not just on a single database, but you want to do something on the server, then what databases you have on that server is definitely important. Now, granted, I would argue that you would want to rely on replication to make yourself a little bit more available, but it definitely does help running multiple Raven servers on a single box, if that's what you're planning to do. Yeah. So another one that is interesting is your business model relies on supporting multiple versions of your product across tenants. Now, Raven's schemaless, so you could technically run different versions of the same document type within the Raven database, and it's totally fine. What I've experienced, though, is that managing that is a little harder when you have multiple versions. When you want to run completely separate systems and you have I mean, and Service Bus does a good job of running side-by-side deployments of multiple versions. Your web servers, you can put in different ones. But it is an interesting deployment strategy to just deploy per tenant. And as you want to release a new version, you can pick and choose what tenants you want to upgrade to. Now, it does come with a huge caveat. This kind of assumes, it gets really complex really quickly because we talked about all these other things of reasons why you would want to move to a separate Raven database. Well, if all of a sudden you do it per tenant, well, when you have one of these split off, now you have per tenant per collection that you're doing. So pick and choose on how you do it, and think about what your SLAs are for documents and what you're putting together when you're doing this stuff. That's mainly the issue. One thing I would say is that RavenDB makes it really easy to skimp on a bad decision, just because you can do selective exports. There's a lot of stuff that you can do to smuggle data in and out to put it on a different server. So some of these are common performance pitfalls that I've seen, that we've seen running RavenHQ that we thought we would want to share. Some of these go to what David and Kajana was talking about. So on the opposite of what David was talking about is modeling documents relationally. It seems kind of obvious, but you can fall into, and I've fallen into thinking about these things very relationally and having a bunch of tiny documents that relate to each other. The problem is when you do that, you end up doing all of these things because you made that decision. So waiting for non-stale results, that's catastrophic, right? A lot of our support tickets come from people saying that waiting for non-stale results is timing out. Well, why is it timing out? Well, I'm writing a few hundred documents, and I'm waiting for this one to come back, and this one index is not done within this amount of time. Well, if you need that type of consistency, then consider using a load instead of using querying for that stuff. It's always they're looking for that one document, and if you're thinking about getting that one document, using load or load starting with is probably a good way to go.
Okay, explain a little bit how the third one impact performance.
Which one?
The third one.
Oh, third. So it doesn't affect the performance of Raven. It affects the performance of whatever you're doing, right? So what you're essentially saying is I want to wait around until this thing is fully consistent before I'll give back a request. So we're at a controller, right? And I go and I do a bunch of stuff, and I want to wait for fully consistent. So I go and say, hey, do this query, but wait till it's done indexing. Well, that could be a minute, right? Or it could be a few seconds, 30 seconds. It could be whatever, right? You don't have control over how long that index is going to take to become fully current, right? So you're waiting around in that request. That's going to affect how many other requests you're going to be able to take at a time as well, right? So that's how it affects performance.
For fun, you may have people doing wait for non-stale result without as of now, as of last data.
That is true, yeah.
Then you have people who basically says, I want to wait until there are no stale indexes.
Right.
If you run this for code, you write and then wait for non-stale result, you have a cascading failure because every write, wait, the next write, wait, and it caused the older write to continue to wait even longer.
Yeah. I can't talk. I'm guilty of that on the Event Store project. So learn the hard way.
So how about we are not using this, okay? We are waiting for the answer for now and then the timeout. For example, 15 seconds.
Well, I mean, then
That will increase the load on the server.
you're waiting around for 15 seconds potentially. I think that's increasing load, right?
Or it will increase the load
You're waiting around for 15 seconds, right?
on the server.
On the web server, right?
No, I'm talking about on the RavenDB.
But someone's waiting around for that, right?
So it will increase the load on the RavenDB.
Yeah, all that you're saying is I want to wait around for a certain amount of time, right, for this thing to become consistent. And if you wait for 15 seconds and it's still not consistent, then it's going to essentially say, hey, we're not consistent still.
There's no extra load associated with that. That's his question.
Say what?
I think he's asking if there is any extra load, like waiting, and there's no.
Oh, on the server? Yeah, no extra load on the server. On your web nodes, there's extra load.
So it's an unsupervised wait notification to tell you. I'm still not getting, because, for example, they're waiting for 50 seconds, right? So they need to wait to know first if they can get the non-stale result in that time, or they need to send out the timeout. How this RavenDB is handled by the client or handled by the server?
The client.
Client.
Right. So the client's waiting around for essentially this thing to go, and then after that amount of time, it's going to, I mean, it's essentially pulling underneath, right, to get the latest E tag.
Okay, in this case, that thread on the RavenDB server will be automatically killed.
What thread?
Hurry, send it to you, that's the request.
Yeah, I mean, you're essentially just asking what's the E tag for this index, right? There's, like, if you go and look at stats,
So
you'll
the
see.
client will come out, right?
Right.
So I don't want that anymore.
Yeah.
So my question is, RavenDB handle that thread properly and discard that?
Yeah, you don't have a request open for 15 seconds on RavenDB. You have essentially your active thread in whatever you're doing. If it's your console app, if it's your controller, whatever thread that thing's running on, that's the thing that's waiting. And it's
Waiting
sending
for
multiple
the
requests in the
request
background.
already sent to the RavenDB server, right?
Well, you're waiting.
That's what time that's active coding. Check whatever the index is.
Right, in another thread.
So how to check that active code? Every couple seconds or how
Every 100 milliseconds.
So that definitely increases a lot. No.
Not really, because I mean, you're just getting back stats. You're getting back an E tag. You're not getting back the whole request. You're just asking, hey, what E tag are we at for this index? Or for all indexes in the case of non-stale results with nothing in it. But what I'm saying is that you're waiting around for consistency. That is going to affect how many concurrent requests you can do,
Yes.
right, on your web nodes. And we're talking about system as a whole, not necessarily Raven performance.
Also affect the RavenDB, right? If you want to wait for 50 seconds.
Not really, no. So if you do have large consistency constraints, consider breaking up your aggregate boundary and having something that you can do a load on for just that document. That's a really important thing. Let's see here. So I think we've nailed this one to death, but having a bunch of tiny indexes on the same collection, one for each property, is a brilliant way to make your indexing slower than what it needs to be. Prefer a smaller amount of indexes that index a larger amount of properties where you can get away with it. Motto nailed that one on the head. He talks, so I won't even talk about it. So another, this isn't necessarily a performance pitfall, but it's more of an ops pitfall, is that a lot of people don't want to deal with replication at the very beginning, and then they go in and they enable the replication bundle after they've been in production for 3 months, right? And then they add a destination and stuff goes over, and then suddenly they get conflicts. I won't go into why that happens because that's going to be covered in the next talk, but it's one of those places that ops-wise you really need to take into consideration, do an import-export, or just consider running the replication bundle by default. Is that the default way 2.5 does it now? No? So make sure you enable replication bundle if you're considering replicating. So not considering the differences in SLAs for different collections. Well, we already talked about that one, but that's pretty important. That's the fundamental thing. If you think about how you're writing these documents, how many indexes you have, and how they're affecting each other, those things are really going to help you decide on if you're going to run on the same database or not, if performance is going to suck. It's because people don't consider that. And then finally, very large consistency boundaries, but essentially these documents that are several megs. Why is my write slow? Why are my writes slow? Why is my indexing slow? We get a lot of those. So what's next for RavenHQ? Well, as Oren mentioned, we're waiting around for Judgment Day, but until then, we're doing a lot to kind of help us do better ops for our customers, and then also making it to where it's easier on our customers to help them scale better. One of the main ways that we're going to be able to do that is we're going to abstract where you're actually running. Along with replication, what that can help with is allow us to move you to better servers or move other people to better servers without having to have you change your connection strings is going to be a pretty big deal. So that's coming down the pipeline here very soon. Provisioned resources is, we actually kind of support it now, but not necessarily on our plans. We have share plans and dedicated plans, but kind of doing a mixture of the two, where you have a shared environment, but you get essentially dedicated CPU, dedicated memory, dedicated disk allocations, those types of things. We're going to automate a lot more of that so that you can kind of fine-tune what you need and help us fine-tune what you need. And yes, Azure. It's been a while. We've been promising it, and we had a few complications. Mainly around disk I/O. We've been working with Microsoft for a while now to try to fix it, and I think we finally got over kind of our last hurdle, and you'll be seeing something very soon on that. So that's it for me. Any questions? Ops related, RavenHQ related? So we do more around in Service Bus, integration within Service Bus, and doing alerts so that we essentially manually move people right now. But as part of the custom DNS stuff, we are starting to automatically move customers who are either highly available because they're on replicated plans and important. Their scale's important to them. We are going to start doing that portion of it. I wish we didn't have to use performance counters for that, but that's the way it is right now. How do we handle noisy neighbors? Well, it started off, we would handle them by, we're able to look at the amount of requests per second per database, and really taking a look at that and throttling their amount of requests, which helps over time. But the problem with that is actually throttling your requests is a CPU burden for us. So over time, I mean, if you're a free database doing hundreds of requests per second, then we'll probably disable you at that point. We can throttle you per tenant, but we have a mixture, depending on what plan you are, a mixture of running on a shared multi-tenant database or if you're running on your own tenant. I don't want to get into the specifics of that because then you can just clone it. No. But there's a lot of heuristics that goes into play when how we make that decision. But generally, the higher up you go in our plans, the more specific we get with what resources we share to you and how easy we make it to help you scale over time, because you're the one who needs it, right? Versus a guy running, his demo database and probably logs into it once a year. Somebody had a hand up over here somewhere? Oh, right there.
You guys have to make any modifications to this?
So not specifically, did we have to make modifications to the studio? So we want to make modifications to the studio, but the Silverlight client is not, it's not very easy to do that. So we do run our own responders, and we have custom ways of the way we do backups. We have stuff to throttle both at Raven and at the IIS level. We do things around being able to migrate you and duplicate indexes, stuff that's just more convenient from an ops perspective. We do responders are awesome, thanks, Oren. Being able, it's very extensible. I've been pleasantly surprised. Try to write your own IIS module and then compare it to writing a module in a bundle in RavenHQ, in RavenDB, and you'll see that's fundamentally easier. Right. Mainly what so he's asking, do we monitor requests to try to find request groups that are common pitfalls to our customers? We don't actively monitor that, though we are planning on actively monitoring and kind of giving you what that instrumentation bundle, what's the thing called for Raven? The MVC integration profiler. Sorry, there you go. What the profiler does, we want to actively start doing that to help everyone, to help you get better at doing what you do and help everyone else at the same time. But what we do is have notifications for when we start seeing that requests are taking abnormally long, especially GET requests are important. And then what we do is we have our own set of reporting, kind of like Splunk, that we use to figure out what profile of things. Does it land on any of these things? And if it does, we contact you and say, hey, you could improve your stuff. Please do it. So are there any bundles that cause problems when adding later? I think the versioning bundle, you can't really add later. Oh yeah, obviously the encryption bundle. But the versioning bundle is, but officially you're really not supposed to add and remove bundles. It's just better. It's safer for you to just turn it on somewhere else, set up replication or smuggle into the thing that you're doing. I'd say the bundle that gives heartache the most, especially running a multi-tenant system, is or a bunch of multi-tenant databases, is the expiration bundle. Not necessarily because it's just pure, the way it's designed is that it runs on other threads, right? To be able to turn on and off, to be able to go and delete documents. So that can be a source of, missing resources after a while if you have enabled on a bunch of databases. But that's really the only bundle that has issues. So we don't support custom bundles, but as part of the custom DNS stuff, we are opening up the ability to run custom bundles and custom analyzers and that type of stuff.
We have like just a very simple one for replication that just lets us
Right.
automatically resolve conflicts because it's not mission critical.
Right.
Allocated to the last one.
Yeah.
And so like that would be an example.
Yeah, so conflict resolvers, I mean, Raven 3.0 kind of takes care of a lot of that stuff for you. But having the ability to run custom bundles is definitely very high on our priority list for that reason. Right now with Raven, we have a built-in conflict resolver, and we'll change out that conflict resolver on a case-by-case basis, or you can deal it with the client side if you want to. On our shared plans, dedicated plans, you do what you want, right?
Yeah, how quickly do you think you're going to follow the roadmap on 3.0?
So we're definitely going to offer a beta. So how quickly are we the roadmap for Raven 3.0? We're going to offer a beta. I think that the bits are a little, it's just not supportable right now. But I'd like to see, what, May timeframe? Yeah, maybe I'll get Oren to blog about it. But we definitely want to offer a pretty long beta. Yeah, so you'll be seeing a lot of cool stuff coming from that. And that's actually helping us do some of the other stuff that we're doing. So we're pretty excited about it.
So for the 3.0, do you think you are going to set up some master one is run on the Ascent, and another one is going to run the Aura storage?
So the question is, are we going to mix and match our ECENT with Voron? I prefer not to. I would like to. It depends. I mean, we're doing our own. I mean, Oren's got his testing. We have our own testing that we do, more from an ops perspective. But I would like to run completely on Voron because ECENT comes with its own set of operational nightmares, especially when upgrading server versions or changing, migrating to different servers. We have to go the smuggling route when using ECENT just to avoid operational pitfalls. So that's important to us, and going to Voron is huge for us. Yeah, so it's 12:05. I don't know what time. Is it right around now? Yeah, lunch. So you guys hate me. I'm 5 minutes over. But if you have any questions during lunch, or if you want to hit us up, hit us up on RavenHQ.com support, or come contact us. If you're using RavenHQ, we'd love to hear from you, what you like, what you don't like. So just hit us up and let us know. Thanks.